What's up, Geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our quiz review for lessons 6.1 through 6.3. This is page 328 on your textbook. So let's go ahead and get started to see how we did here. Number one, we are looking at a bisector for finding the length of UV. So what we do know is that SV is equal to UV because of that perpendicular bisector right here. So what we can do is we can take our two expressions, 2x plus 11, and set it equal to 8x minus 1. We're going to go ahead and solve for x here. And we get x is equal to 2. Once we do that, we just plug it in to one of the following questions. I would do 2 times 2 plus 11. That's going to be 4 plus 7, which is 15. So UV is equal to 15. Okay. For number 2, it also looks like we are having some bisectors. So we can say that PQ is equal to RQ. So we would just take 6x equals 3x plus 9 minus 3x on both sides. We get 3x equaling 9. X is equal to 3. So if we do 6 times 3, we get 18. So QP is equal to 18. As far as explaining your reasoning, the first one is a perpendicular bisector. And then for this one, we have an angle bisector. Okay. Number 3, find the indicated measure of GJK. GJK is here, GJK. So we would just need to know what that piece is. If you look at GJ, it is an angle bisector. So HGJ will be equal to KGJ. Okay, which means the 5x minus 4 would be equal to the 4x minus 3. So 5x minus 4 is equal to 4x plus 3. I'm going to go ahead and move my x's to the left side because that gets rid of them right away. So 1x is equal to 7. So now we know x is equal to 7. You just plug it into one of those problems. 4 times 7 is 28 plus 3 is 31. So if this is 31 degrees, that's 90 plus 31, which is 121. And then you just take away from 180, and that'll give you your leftover of 59 degrees for GJK. Okay. Number 4, find the coordinates of the circumcenter of the triangle with the following vertices. We're actually going to skip over these and look at how we could possibly draw them in a coordinate plane. So let me take a moment and paste a coordinate plane in here, and then we'll get right back to it. Okay, for the circumcenter, that's where you're in the middle of everything. So what I would do is I would just find the distance between B and C is 1, 2, 3, 4. So halfway is 2. I can mark it like this. The distance between A and B is 6, so I would count 3. We'll do that in a different color. 1, 2, 3. And then after that, it should be able to tell you exactly where those are, which is at -2, -1. Okay. Same thing over here. We're going to plot our points first for number 5 and then figure out our circumcenter. What I also went ahead and did here is after I plotted all my points, I went ahead and found the midpoint of DE and EF just because a little bit harder to do on a diagonal line. The midpoint for DE is 5, 7. And then the EF midpoint is 9, 7. So as you use those to help you, you should get your circumcenter at 7, 5. Okay. Onward to number 6. We have the incenter of a triangle ABC is point N. Use the given information to find the indicated measures. NQ is equal to 2x plus 1 and NR is equal to 4x minus 9. Because these are incenters, that means NQ is equal to NR. So we would just start off by setting up a equation. 2x plus 1 is equal to 4x minus 9. Go ahead and move your variables to one side. I always start with the smallest just so I don't have to worry about negative variables. So I get 10 is equal to 2x. That means x is equal to 5. NS is also going to be the same length as either one, so you can use either expression. I'm going to use 2x plus 1, so that's 2 times 5 plus 1. I get 11. So NS equals 11. For number 7, almost the same thing here. We have NU and NV, find NT. The incenter represents the perfect center point, so negative 3x plus 6 is equal to negative 5x. I'm going to move my negative 3x, so I only have to move one thing. So I get negative 2x is equal to 6, so that means x is equal to negative 3. To find my NT, I'm just going to plug that in right to this original problem. Negative 5 times negative 3 is 15. So NT equals 15. Again, number 8 also has an incenter. Triangle ABC is point N for the incenter. Use the given information to find the indicated measure. NZ and NY are equal to one another. So now we can use that to find NW. So I got 4x minus 10 equals 3x minus 1. Let's move that 3x over, add 10. We're going to get x is equal to 9. So plug it in. 3 times 9 is 27. Minus 1, 26. So NW equals 26. Number 9 is another graphing one. So it'd be helpful if you had some graph paper for this one. Let's go ahead and plot all these points for J, K, and L first, and then we'll talk about how to find that circumcenter, or the centroid, excuse me. All right, remember the centroid can be found by using perpendicular bisectors. So you can start with letter K and perpendicular bisect. It's kind of hard to draw on the computer. And then L, and then J. And it looks like our centroid is right here, meeting at this point, 3, 2. Again, another centroid, so go ahead and take time to plot your points first, and then we'll find the given vertice of that centroid in just a moment. All right, so we've got our triangles with the following vertices. Now we're just going to do the exact same thing as we did before. It's going to be helpful if I use a straight line measurement this time, so let's do that. So N to MO, O to MN, and then M to O, and it's going to be intersecting all at the same point here. So this is negative 4, 1, 2, 3, 4, negative 4 for your centroid. Okay. Number 11, tell whether the orthocenter is inside, outside, or on the triangle, then find its coordinates. I say it would be helpful to draw your triangles first, and then you can find the orthocenter a little bit easier. So let's go ahead and do that both for 11 and 12. Okay, so I've got our triangles drawn for 11 and 12. Again, to find your orthocenter, it is best to find the perpendicular slope first so that you know you're going to be looking at the correct way to do that. So if you were looking for the perpendicular slope of TU, that's your change in Y. So I go 5 minus 1, that's 4, over your change in X. Negative 2 minus 0 is negative 2. So this one's M is negative 2. So that means for TU has to start and go through point V. I'm going to go down or over 2, down 1, over 2, down 1, and it's going further away from there. So I'm going to have to go back on the other side. start at T, go over 2, down 1, over 2, down 1, over 2, down 1. So I've got this little line forming here. And then we can maybe do VU, 5 minus 1 is 4, 2 minus 1 is 2, so that slope is positive 2. So over 2, up 1. Starting at letter V, over 2, up 1, left 2, down 1, and you can already see that orthocenter is right there in the middle at 0, 4. Okay. With this one, it looks like a right triangle, so it's probably going to be on the orthocenter. Let's go back here and we're going to say inside. This one was an acute triangle. So looking at this one, again, we want to find that perpendicular slope to one of the lines. I'm going to maybe try XZ. So the XZ, 4 minus negative 4 and 7 minus negative 1. That'd be 8 over 8, which is equal to 1. So for this whole entire thing, my slope is going to be 1 over 1. And if you look right across from XZ, Y is perfectly right there. So my orthocenter is going to be ending up right here on this right triangle here at 7, negative 4 on triangle. Okay. All right. Back to some word problems. We have number 12? Yep, so we're on 13. Okay, a woodcutter is cutting the largest wheel possible for a triangular scrap of wood. The wheel just touches each side of the triangle as shown. What type of concurrency is the center of the circle? For this one, we're going to say we can use the incenter. What type of segments are BG, CG, and AG? Those look like angle bisectors. So they're bisecting angle A, angle B, angle C. Which theorem can you use to prove that triangle BGF is congruent to BGE? That one we can use the hypotenuse leg theorem. And then C says find the radius of the wheel to the nearest tenth of a centimeter. Justify your answer. For this one, what I might do is think about it as a right triangle within there. Maybe if I did 8, 7, 3 minus 10 is 7. So this, if I take away 3 from, because BF would be the same thing as BE. So I can focus just on one triangle here, and I can maybe find the measure of X for this. This would be taking away 3 though, so I could redraw this triangle as 7, 8, and an X. So I could do X squared plus 7 squared plus equals 8 squared. So that's X squared plus 49 is equal to 64. X squared is equal to 15. So if you find the square root of 15, it's going to be about almost 4. So I'd say about 3.9 centimeters. And all we did was we used the Pythagorean theorem and the congruent triangles theorem to show that from E to A would be just taking off 3 centimeters because BF is equal to BE, and from B to A is 10. The last one says the Deer County Parks Committee plans to build a park at point P, equidistant from the 3 largest cities X, Y, and Z. The map shown was created by the committee. Which point of concurrency did the committee use as the location of the park? They tried to use the centroid here, but if you are using the centroid here, it would not show everything being equidistant. So no, it's not equidistant from each city. Should use the circumcenter. Okay, so that's going to help maybe make a better decision next time. That's going to conclude our quiz review for 6.1 through 6.3. Thanks so much for hanging in there. Good luck on your quiz tomorrow, and